Welcome back. In this lecture, let us see how to define a conditional event. In the last lectures, we have seen the conditional distribution f(x) of x given b as the probability of the joint event x less than or equal to small x intersection b by probability of b, where probability of b is not equals to 0. Now, what is b? The question is, what is b? How to define it? This is the topic. How to define it? So, the event b can be defined in two ways. The first one is event b is same random variable x. Same random variable x. Second way is event b is other random variable y. Other random variable y. Two ways we can define in these two ways. One is b is an event which is in terms of the same random variable x, and other one is event b is other random variable y in terms of other random variable y. Now let us see the first case. First one, event b is the same random variable x which is less than or equals to b. Here b is a real value from minus infinity to plus infinity. Let us see what are the conditional distributions and what is the conditional density function for this first way. Just now we have seen that conditional distribution of x given b. Now b is nothing but x less than or equal to small b. This we can write as the probability of x less than or equal to small x intersection x less than or equals to b all divided by probability of x less than or equal to small x less than or equals to b, where the probability of x less than or equal to small b is not equal to 0. Now let us see two cases in this. Case 1, small x less than b. Small x less than b. Now let us see the joint event. What is here? Joint event x less than or equal to small x intersection x less than or equal to b. Let us talk about this. Now x less than or equal to small x in this case is the subset of x less than or equal to small b. Because b is greater than x, then x less than or equal to small x will be the subset of x less than or equal to small b. Then the intersection between these two, or the joint event x less than small x intersection x less than or equal to b, will be x less than or equal to small x. Now we can write the conditional distribution fx of small x given x less than or equals to small b as the probability of x less than or equal to small x divided by probability of x less than or equal to small b. If we see these two probabilities in the numerator and denominator, those are the probabilities of x less than or equal to small x and the probabilities of x less than or equal to small b. Those are CDFs. Those are cumulative distribution functions. So we can write the numerator as CDF of small x, CDF up to small x, and the denominator is also CDF of the random variable x, it is up to b. This is the conditional distribution function for the first way of defining conditional event b. Okay, now let us see what is a small fx of x given x less than or equals to b. This is a conditional density function. How do we obtain the conditional density function? The distribution is nothing but the differentiation of the distribution function. CDF is nothing but the differentiation of CDF and PDF. Okay, we have seen these two. We can obtain the PDF by differentiating CDF, or in reverse, CDF can be obtained by integrating PDF. Okay, already we have obtained this conditional distribution function, conditional CDF we have obtained. Now we need to find out the conditional density function. So we have to differentiate the conditional distribution function d by dx of capital Fx of x given x less than or equal to small b. So this is nothing but differentiation of the conditional distribution. Only numerator is a function of x and the denominator is the CDF of 2b, which is nothing but constant. So the differentiation of the numerator is differentiation of fx of capital Fx of small x is nothing but small fx of x, and the denominator is CDF only, CDF up to b only, it is constant. This is for case 1 x less than b. Now let us see the case 2. This time let's take x greater than or equals to b. Now this time x less than or equals to small x, or x less than or equal to b will be the subset of x less than or equal to small x. Let us go to the first case. X less than b. In this case, x less than small x is the subset of x less than or equal to small b. Now here b is the subset of small x. Now what is the joint event? The joint event is x less than or equal to small x intersection x less than or equal to small b. So the intersection of these two is the subset one, x less than or equal to small b only. Now let us apply this the conditional distribution. So we can write this as a numerator is the probability of x less than or equals to b, and the denominator is the probability of x less than or equals to b. So both are one and same. the numerator denominator are same, so this leaves us 1. Now let us write the conditional density function x given x is equal to b, which is the differentiation of the conditional distribution function capital Fx of x given x less than equals to b. So in this time this is 1, the CDF is conditional CDF is 1, differentiation of 1 is 0. Now let us write the conditional distribution and conditional density functions at one place. Fx of x given capital X less than equals to b, it is Fx of x by Fx of b. This is for x less than b, this is for small x less than b, and it is 1 for x greater than equals to b, right? And conditional density functions x given x less than equals small b, this is nothing but small Fx of x by capital Fx of b for x less than b and 0 for x greater than equals to b. Now if we see this x less than b condition, the denominator is the denominator, what is the denominator here? Fx of b. We know that this is in between 0 and 1, this is in between 0 and 1, the CDF is bounded by 0 and 1. Let us take, let Fx of b is 0.1. now let us write Fx of capital Fx of x by excuse me, let us write this Fx of x given x less than equals to b is equals to Fx of x by small f capital Fx of b, and here also let us write the density small Fx of x given x less than equals to b is equals to small Fx of x by capital Fx of b. Now let us take this 0.1 Fx of b equal to 0.1 and substitute here Fx of x by 0.1 and here small Fx of x by 0.1. This 0.1 goes to the numerator and it becomes 10 times the CDF of x, and here also 10 times the PDF of x. Right? So from this we can say that the conditional distribution function, now it is greater than small Fx of capital Fx of x. The conditional distribution function is greater than the original CDF function. How many times? It is 10 times greater than that. Similarly, the conditional density function also greater than small Fx of x. So in this example it is 10 times, the conditional density function is 10 times greater than the individual density function. This conclusion is very important. So this is about methods of defining conditional event, and that too we have discussed the first method. The event b is the same random variable x. So we have derived the conditional distribution and conditional density function. Thank you.